Have you ever wondered what will happen when the sun burns out? At the heart of our solar system, the sun, a luminous orb of fiery plasma, sustains life on Earth with its warm, radiant energy. Currently in its stable middle-age phase, our sun has been the unwavering center of our cosmic neighborhood for about 4.5 billion years. Each day it rises, casting light and warmth, driving the climate and weather patterns, and fostering the conditions necessary for life as we know it. But the life of a star is not eternal. The sun, much like any other star in the universe, is on a journey, a cycle that began billions of years ago and will end far beyond our lifetimes. As we speak, it is slowly consuming the hydrogen at its core, the very fuel that keeps its fiery furnace ablaze. But even stars have their limits, and our sun is no exception. To understand the sun's future, we must first explore the journey of a star. The birth of a star begins in a vast swirling cloud of gas and dust known as a nebula. These celestial nurseries are scattered throughout the cosmos, cradling the raw materials necessary for star formation. Within these nebulae, pockets of gas, primarily hydrogen, start to collapse under their own gravitational pull. As these gas clouds condense, they heat up, eventually reaching temperatures where nuclear fusion can ignite. This fusion process marks the birth of a star, and our sun was no exception. About 4.6 billion years ago, within a nebula, the sun sparked to life. As the newborn star settled into its existence, it entered what astronomers call the main sequence phase of its life cycle, the stage where it currently resides. The main sequence is characterized by a delicate balance. In the core of the sun, hydrogen atoms fuse to form helium, releasing vast amounts of energy. This energy travels outward, providing the light and warmth we feel on Earth. The outward push of this energy counters the immense gravitational force trying to compress the sun, creating a stable equilibrium. During this phase, the sun converts millions of tons of hydrogen each second. It's a process that sounds prodigious, and it is, but the sun has an abundance of hydrogen. It's estimated that the sun has enough hydrogen to continue burning for about another 5 billion years. Yet this stable phase of balance, where the sun spends most of its life, is not permanent. As the hydrogen in the core depletes, the sun will face a shortage of nuclear fuel, and this will disrupt the equilibrium. The core will contract under gravity, temperatures will rise, and the sun will embark on the next stage of its stellar evolution. This phase of balance will not last forever, setting the stage for dramatic changes. As the sun ages, its fuel diminishes, leading to a spectacular transformation. This pivotal moment in the life of our sun begins when it exhausts the hydrogen at its core, the very fuel that has kept it burning for about 5 billion years. What follows is a dramatic change, transforming our dependable star into what astronomers call a red giant. In this new phase, the core of the sun, now densely packed and rich in helium, contracts under its own gravity. This contraction increases the temperature and pressure in the core to such extremes that it triggers the fusion of helium into carbon. Meanwhile, the outer layers of the sun respond quite differently. No longer able to sustain the calm equilibrium of its younger years, these layers start to expand massively. Imagine the sun, which has always seemed a constant in our sky, swelling to a size that is up to 250 times its original diameter. This colossal expansion is not just a spectacle, but a cataclysmic event. As the sun grows, it engulfs the orbits of the closest planets, Mercury and Venus. Even Earth might not escape being swallowed by this expanding stellar behemoth. As the sun expands, its surface cools down considerably. From the blistering millions of degrees at its core, the surface temperature drops to about 3,200 degrees Celsius. This cooler temperature imparts the sun with a reddish hue, a characteristic feature of red giants across the universe. Throughout this transformation, the sun loses a significant amount of mass. The outer layers, now loosely held by gravity, are pushed away by intense stellar winds. These winds carry away material, contributing to the creation of what will later become a planetary nebula. This expansion marks the beginning of the end for our once familiar sun. As we witness this grand but grim spectacle, our sun transitions from the main sequence of its stellar life cycle into the twilight of its existence, setting the stage for its ultimate fate as a white dwarf. After the red giant phase, the Sun embarks on a path to becoming a white dwarf. As the Sun exhausts its nuclear fuel, its outer layers begin a dramatic transformation. These layers, no longer able to sustain the immense gravitational pull, drift away into space, creating what we know as a planetary nebula. This spectacular event paints the cosmos with vibrant colors and intricate patterns, a celestial farewell from a dying star. What remains after this cosmic shedding is the core of the Sun, now destined to become a white dwarf. This core, incredibly hot and unimaginably dense, is a mere shadow of the Sun's former glory. It's fascinating to note that despite its small size, typically comparable to that of Earth, it retains much of the Sun's original mass. A white dwarf is not just an end, but a significant marker in the journey of stellar evolution. It represents the final stable stage for stars like our Sun. In this phase, the white dwarf will continue to radiate heat left over from its previous life, but it no longer undergoes nuclear fusion. Over billions of years, it will radiate away its heat until it reaches a point where it no longer emits significant light or heat, becoming a so-called black dwarf, a theoretical celestial body that the universe is not old enough to contain yet. The existence of white dwarfs provides crucial insights into the future of our solar system and the ultimate fate of many other stars in the universe. These stellar remnants are also key to understanding more about the properties of matter under extreme conditions. As researchers study white dwarfs, they gain insights into the behavior of atoms in states that cannot be replicated on Earth. In observing the transformation into a white dwarf, we witness the Sun stripping down to its core essence, revealing the fundamental elements of its composition. It's a profound reminder of the cycles within the cosmos, where endings are merely precursors to different forms of existence. In this compact form, the Sun's story approaches its twilight. What remains when a star like our Sun finally dims? The journey of a star through the cosmos is long and eventful, but all must eventually come to an end. Even our Sun, the giver of life and light, will one day find its final repose in the quiet of space. As our narrative reaches the twilight of stellar evolution, we encounter the concept of a black dwarf. This is not merely the end, but the profound silence after the story has been told. A black dwarf represents what becomes of a white dwarf after it has radiated away all of its residual heat, a process that spans unimaginable lengths of time. Consider the white dwarf, already a remnant of a star that has shed its outer layers and ceased nuclear burning. Devoid of fuel, it slowly cools and fades over billions of years. But the journey from a white to a black dwarf is not one we have witnessed. Our journey through the life cycle of the Sun brings both awe and a poignant reminder. From its fiery birth in the nebula to its steady burn in the main sequence phase, the Sun's life is a stellar narrative of light and energy. We've seen it expand into a red giant, engulfing its surrounding planets, and later shrink into a white dwarf, marking the end of its nuclear burning days. Eventually, it will fade into a black dwarf, a cold relic of a star that once was. Throughout these transformations, the Sun remains central to the existence of our solar system. Its changes dictate the fate of our planet, influencing everything from the climate to the very continuation of life on Earth. As it progresses through these stages, the Sun exemplifies the life cycles of countless stars scattered across the universe, each playing a role in the cosmic ballet. Though the Sun's end is billions of years away, its life reminds us of the fleeting nature of existence in the cosmos.